If you don't know what 1 over 7 is as a decimal off by heart, then you are burning time that you cannot afford. I'm going to show you exactly what to memorize so these become instant. My name is Farhan, I'm a junior doctor, and I've helped over 100 students get into medicine and dentistry across Australia. And today, you are going to learn how to get quicker at fractions, decimals, and percentage questions via a conversion table. And also how to stop getting confused when it comes to ratio questions. Look, when it comes to fractions and decimals, everyone, including you, can do this, but that's not where the gains are made in QR. Where the gains are made is when it comes to mental maths. It's being able to mentally convert between fractions, decimals, and percentages with speed. So if you're already quick at this, then good on you, but you can get faster. If you're slow at this, then now is the time to work on it. And the way you work on it is by committing this conversion table to memory. So here's what it looks like. And here's what I want you to go through. So just commit this entire thing to memory. Screenshot it, do whatever you want with it. Just memorize it one way or another. I tend to do well with flashcards. So if you want to, maybe occlude this in your flashcard app and then have it come up for you to guess, or rather recall, then do that. So essentially 1 over 2, 1 over 3, 1 over 4, 1 over 5, and 1 over 10, you guys should already know. If you don't already know these, then I don't know what to tell you. My baby cousins know what these are. But some of the ones that might need a bit more thinking are these ones. So let's go through them, right? 1 over 6. The way I remember this is I just remember it as 1 over 3 and then 1 over 2. So half of 0.33 is how I remember 1 over 6. And if you want to remember 0.167 or around 17%, then do that. 1 over 7 is a bit of a tough one, because you can't really rely upon any of the other numbers to help guide you like we did for 1 over 6. So what I do for this one is I just try and remember that 1 over 7 is equal to 0.14. And the way you remember that is 7 times 2 is equal to 14, and 14 is the number that goes on the right-hand side of the decimal place. So a nice, convenient way to remember that. 1 over 8 is the same thing as the 1 over 3 and into 6. It's just half of whatever 1 over 4 is. So this says 13%, but really you know that that's 12.5%. This is just rounded to two places. So remember that as 12.5%. And then 1 over 9 and 11 are, they might look a bit confusing to begin with, but once you recognize that they're kind of just the inverse of one another, then it becomes really easy. So 1 over 9 is equal to 0.11, and then 1 over 11 is equal to 0.9 or 0.09. So they just swap in this case. So that is how you can commit this basically to memory. And the reason why I suggest for you to commit this to memory is because it'll help you when it comes to the mental math side of things. These kind of calculations aren't necessarily what you want to be putting into the calculator. I mean, you can if you want to, and it shouldn't take you that long at all if you're confident with the calculator, but the more inputs you put into the calculator, the higher the likelihood of error and mistakes. That's just fact. So if you can avoid it by doing mental maths, then do so. Now, if you want this conversion table alongside all of the other methods and frameworks that I have for the UCAT all in one place, then just click the first link in the description below. Otherwise, let's move on to ratios. So when it comes to ratios, the only real important thing to note is the wording. This is where most people get caught out. It can be the difference between getting a question right and wrong, even though you knew the maths behind it. And here's the key, right? The ratio of lemons to oranges does not equal the ratio of oranges to lemons. Or in other words, the order matters. So let me give you an example. There are 50 cars and 150 vans. What's the ratio of vans to cars? Is it 1 to 3 or 3 to 1? The answer is 3 to 1 because I'm asking for vans to cars. So vans, how many of them? 150. To cars, how many of them? 50. So simplified, that ends up becoming 3 over 1, which was our answer. So that's kind of all you need to know. This isn't complex. It's just about how quick you can be with it. So let's go through some worked examples. So feel free to pause the video now and have a go. All right, so let's go through this question together now. So we've got 2/3 of the women who visited the museum, so here, and 5/12 of the men who visited the museum did not purchase a guidebook. What percentage correct to 1 decimal place of the adults who visited the museum? So this is the total. Okay, I'm just going to write total here. did purchase a guidebook. This is where reading the question becomes really important. So we're getting the numbers here of the people that did not purchase the guidebook, and we're aiming to figure out what percentage did. So what I'm going to do here, just to make my life easier, is actually change this to 1/3 and change this to 7/12, just so we save ourselves 1 or 2 calculations and get to the answer quicker here. So let's do that. So we're trying to find out the percentage that did buy a guidebook. We know 1/3 of these people did, and that ends up giving us around 16 people. And then 84 here, if we multiply by 7/12, 84 divided by 12, that's 7. So 7 times 7, that gives us 49. So here's the number of people that did buy. So we can pop that straight into here. So 16 plus 49 gives 65. And then the total number of people is 48 plus 84. So that's around 132. So I can't do that in my head. So 65 divided by 132 on the calculator gives us 0.492, or in other words, our answer of C here, 49.2%. But hopefully you can see here just how being confident with your fractions, and especially when it comes to mental maths, we didn't necessarily have to do any conversions here, but just being able to work with them at a mental maths level helps us save so much time. You can pop all of this into the calculator if you wanted to, but I really only needed to put one thing into the calculator here, which made the likelihood of making an error so much lower. That is if you're confident with mental maths. If you're not, then the likelihood of error skyrockets, because if you get this number wrong, then you get the percentage wrong, right? So I'll leave it up to you. You can use the calculator for everything. That's what I did, but there are opportunities for mental maths on the day as well. Here's the next question. Feel free to pause the video and have a go. Alrighty, so let's run through this one now. If 25% of the women who said they did not visit a museum had in fact visited but forgotten, then what would be the ratio of women who visited the museum to women who did not? So let's remember the wording. It's visit to not visit, just like it has in this order. So shouldn't really be all that confusing. Now, 25%, what do we know from our conversions? That is 1/4. So when it comes to this, 32 divided by 4, that ends up giving us the number of 8. So we know this is going to be plus 8, and we are going to end up minusing 8. I'm just going to write that here for now. So that ends up becoming 56, and this is 24. So our ratio is 56 to 24. Unfortunately, that's none of these numbers, but if we simplify, we can see that our answer B sits nicely. So we divide all of these by 8. That gives us our answer of 7/3. So B is our answer here. All right, and let's move on to our next question. So pause the video here and have a go. Alrighty, so let's go through this question together now. So the ratio of devices manufactured to the devices recalled in 2010 was. So we've got the device manufactured to the ones recalled. So it has to be this one on the left-hand side and this one on the right-hand side. In 2010, so we're looking at the first row here. So we've got 420,000 and then 4,200. So really, all we need to do there is cross out the zeros, and we end up getting 100 to 1 as our ratio here. Basically, the most common mistake you could have here is putting 1 to 100 instead if we flipped the ratio around. So the answer here is D. Now, if you're sticking around this long and you're actually going through the practice questions with me, then good on you. I'm going to pop in a bonus here just to reward you for sticking around and doing these questions, right? So let's just say we've got a complicated ratio here that we're not sure really how to bring this down any further. And you could divide it by 2, but then like how much longer can you keep on dividing by 2 until you get to the answer? And even then you might not get to the final ratio of the simplest form. So if you want to have something like this in the simplest form, then I think it's called the Euclidean method or something like that. That is what you can use to get to the simplest answer. And I'll show you what that is, right? So first of all, we try basically just doing this bigger number into the smaller number as a division. So if you remember this one, right? 420,000 divided by 4200, that'll just give you 100, which means that it's going to be a 100 to 1 ratio. So this divided by that gives you 100 to 1. Whereas if we put 1260 divided by 756, we don't get such a beautiful number. We get 1.66 recurring. And so what that means is only one of these goes into 1260. And so what we do is we get that remainder. So we get 1260 minus 756, and then we work with that. So that is 504. So now we work with the number 504 and do the same thing, just with the smaller number now instead. So 756 divided by 504, you can see will give us, what does it give us? It gives us 1.5. So still not an exact match that we're looking for. So we're either looking for a number 1 or a number 2 or a number 3, anything with a 0.0 at the end. Because this has a bit of a remainder, we're not satisfied. So we go further until basically we hit a solid integer number like this. So 756 minus 504 gives us 252. So we use this number one more time, the remainder, and then go here again. So 504 divided by 252, and that finally gives us 2. So we know that this is the greatest common denominator between these two numbers. And the reason this number is now so useful is because if we do 1260 divided by 252, that gives us 5. And if we do 756 divided by 252, that'll give us 3. And so our final answer here for our simplest ratio is 5:3. So I know in some cases, maybe like once a mock, something like that could come up. It's just good to know for when it does. Otherwise, let's move on to just one more question for ratios. Actually, sorry, you know what? I think this question's a tad too easy. So what I'm going to do is I'm going to change this from 3/2 to 7/5. Because if I teach you how to go about this question, then you'll know how to go about any of these type of questions. Whereas with the ratio 3:2, we basically kind of get lucky because the difference between these is one part, and that's what you end up with if you divide by the sum of the parts, and you'll see as I go along. So if you did the original question and you got the answer of A, then fantastic. If you didn't, then we're going to use 7/5 instead anyways, and we'll explain that. So let's go through it. So we know that if the ratio of adults to children living in the area in 2000, so 2000, we've got the total amount of people living there, 58,000 times 4.2, that gives us the answer of 243,600. So that's the total population that we're working with. Now the question's asking how many more adults than children were living there if the ratio between them was 7:5. So the way we figure this out is what I like to do is I like to take the sum of these two numbers. So 7 and 5 gives us 12. So using that number, we'll then divide the population by that number. So 243,600 divided by 12 gives us 2,300. Now, the reason I'm doing this is because it allows me to figure out what one part of this ratio is, or like one unit of this ratio. If you can imagine, this 7:5 ratio is built up of 12 units or 12 parts. This allows me to figure out what 1 is. And once we have 1, then we can figure out anything. It's like unitary method if you looked at the percentages video, right? So with that in mind, we can see if there's adults and there's children, then we've got 7 parts here, we've got 5 parts here. What's the difference between those two? It's 2 parts. That's going to be the difference in population, the 2 parts. So what do? We multiply this by 2 to give us our answer of 40,600 people. So that would be a final answer if we were working with the ratio 7/5. So you can see why maybe if we had 3:2, the moment you divide it by 5, you will have gotten your answer. So this is just a bit more of a complicated one where you go an extra step to actually multiply it by the difference of the parts to give you your answer. And once you know how to solve this, you'll basically know how to solve any ratio question that comes up like this. So thank you for bearing with me changing that question. Otherwise, we've just gone through a couple of questions to get familiar with fractions, ratios, and decimals. And if you want more questions and you don't already have access to a question platform, then you can use the code Farhan for 10% off med entry. Otherwise, here are just a couple of traps that students fall into when it comes to this. Number one is spending too much time on conversions. Guys, this has got to be lightning quick. You need that committed to memory. Two is mixing forms like fractions, decimals, or percentages within the same calculation. You just get confused this way, so stick to one. And three is reversing ratio order. It's the cardinal sin of ratio questions. So here's your do's and don'ts. Do memorize the conversion table. Do convert everything into one common form before you start calculating, and do read ratio orders carefully. Don't waste time like re-deriving 1/4 equals 25% or 1/5 equals 20% in the exam because one, you should know them, but two, hopefully you've committed the rest of the fractions of the conversion table into memory now as well. Don't mix 0.2, 1/5, 20% in the same working line, stick to one, and don't flip ratios by guessing. The order in the wording matters. So here's your next step. Memorize the conversion table. If you like, set up a flashcard application like Anki or Remnote or whatever it is and memorize the fractions that way. And practice more than just 1/9, right? You can try 4/9 or 5/7 just so you can get ultra quick at knowing the common fractions.